We're diving deeper into C++. Let's take a look at functions. We've done functions in Python. There are no functions in Java. Everything in Java is a method. Everything in Java is object-oriented. C++, like Python, has functions. There are some little short tutorials that take you through the basics of functions. We have parameters, arguments, multiple parameters, return values, overloading. We're even going to do some recursion. So modular. Functions are building blocks. They can also be called modules, methods, procedures, sub-procedures. We've worked on dividing our programs into classes, into functions, into methods. Functions and methods should do one thing and do one thing really well. So why use functions? There it is, divide, conquer. You solve one problem at a time. Get that function to work, then move on. You can have more than one developer working on a program at the same time. Avoids repetition of code. So we have, yes, all that. So we are going to have, we have functions with no parameters, return values, parameters, no return value in both. Well, we have something different in in Python. So let's pause for, here we go. We're going to have a function called message. Well, the convention in in C++ is to put a function prototype. If you don't put in a function prototype, all the functions have to be at the top of the program. Because when you hit main and hit this, the compiler has to already know about message. Well, if the message is down here, you're going to get a compiler error. So if we put a prototype up here, we're warning the compiler that yes, there will be a void function. Don't worry about it. Get started compiling. And then the compiler says, oh yes, here it is. Here's my little function. So if you remember Mr. Mbot, our friend from a year or so ago, he used C++. Void function means nothing comes back, nothing is passed in. It does exactly the same thing every single time. So we're going to do a first function call, and then we print our message 3 times. We call the function, we go down, we execute the function. When we're at the end of the function, we go back up to here and then go to the next line. We have been there and done that before. So let's open this up. Let's clear this out. I don't know where all that stuff came from. All right. So we want to run our void. There it is. And there it is. So there's our print. Ran the function once, ran the function once, ran the function once. The function's always going to be the same. It's always going to do the same thing. That's the nature of a void function. Well, let's move on to the next one. Because we have other types. We have functions with parameters. Just like in Python. Just like in Java, except in Java we don't have functions. We have methods. All right, here's our function with a single parameter. And we go back up to the top. Now we have our function prototype. We're warning the compiler. We're saying, listen, buddy, don't get upset. There is going to be a function called find square root coming along. It's not going to return anything, but we are going to pass in a parameter, so each time we can find the square root of another number. Now we're including the CMath library because that has the square root function. We're also doing something that's a little more complex in C++, something called set precision. So this is the I/O manipulation library. So input-output manipulation. So we're going to initialize some variables. We're going to find the square root of those, right? And then we're going to return. So here we are, square root. We're going to call, without our math library, we wouldn't be able to make the square root. And we're going to do the cout here. Now, set precision sets the precision for anything after that point. So in this, it's going to set the precision for 15 for everything else that comes out of here. So 15 is for a double. What does it say? Oh yeah, C++, a double has 15 digits of precision. Cout will normally truncate the display unless you use C precision. So if we run, C precision, set precision. So we run our little program, which I forgot what it was called already. Oh yeah, function. Function add two numbers, multiple parameters, overloading, return value. There it is, single parameter. There we go. Now notice that these are exactly the same, but the decimal point is in a different place. When you're saying 15 units of precision, that includes all numbers to the left and the right of the decimal. We're not saying that from the decimal over, we're saying that the entire number has 15 units of precision. So if we have a huge number in a double, we aren't going to have much over here in the decimal place. All right, so we just did a single parameter. What do you suppose is next? Oh, yeah, kind of a review of Python a little bit, isn't it? Except for the function, let's see, let's find this first. There it is, except for the function prototype. That is a little different, but that is how you work with C++. We're learning the syntax of C++. We already understand, having multiple parameters. So here we go. We're initializing variables. There we are. There's our three things we're putting in there. When we go down to the multiply function, there's a place for them to come in. Just like Java, just like Python. Do our stuff. Come back up to here. Do the next one. Okay, so same concept. This is the third time we've hit it. Should be just second nature for you. So what else? What's next? Return values. Yep. So we can send something in. So here's our get ceiling. Our get ceiling needs our math library. So what is a ceiling? If you are rounding off a number, normally you round it off, like if we have 2 and 3, we'd round it off to 2.5, for example. Well, a ceiling, if you divided 2 and 3, you'd end up with 3 because it rounds it up. So this one's going to get rounded up. This one's going to get rounded up. So we end up with 5 and 9. Ceiling says go to the highest integer. So we're calling our function. We go down here, we use our ceil. This is a little fancier way of documenting a function. Create a little internal variable so that we can return our result. We find the ceiling number of that, which is the rounded up to the nearest integer, return it, and Bob's your uncle, it works. Again, very similar to what we've done before. And let's make sure it works. There we are, multiple parameters. Ta-da! There we go. It's nice when things work. Doesn't always happen. Now, function overloading is something we did in Java. So let me find my function overloading. Up, there we are. So function overloading means having the same function signature with different parameters. Sorry, the same function name with a different signature. The signature is we have a return value of int. We have one parameter. Here we have two parameters. Here we have the first one is an int, the second one's a string. This one has both of them a string. So how does the compiler recognize that and get the right one? Well, that's where we have our function prototypes. You can also set a default value, just like we can in Python. You can say get result. Well, you can do this in Java too, I think. I don't think we did that. Anyway, get result, if you don't pass something in, it just uses 24, which that should be 42, shouldn't it? Anyway, 24 is the reverse answer. And then we pass in one int with a string, we pass in two strings, and the compiler knows when it gets here, it says, oh yeah, you are destined for this one, you are destined for this one, you are destined for that one. So it knows where to send the code as it's creating everything, compiling everything, converting our text into binary computer code that the operating system can understand. So this is what we can use to parse an integer from a string. So stoi takes a string value and converts it into an integer. All right, function overloading. I don't think we need to see that. That all makes sense. And of course, we have users that don't do what they're supposed to do. They will type in something that's wrong. So we need to have a try catch functions. Input function, where's my input function? There it is. So try catch, it's hard, okay. So we have there's our function prototype. We need our string library to convert the string into a double. Notice it's stoi for integer, stod for double. So we're going to call our function getDouble. And in our function, we're going to prompt the user for, we're going to print the prompt. Oh, there it is. There's our prompt. We're sending our prompt in through the string. Then we're getting our information, right? So we're going to get the entire line into a string. And then we convert it into a double. And we're going to return that double. If we type in something stupid that doesn't work, we catch the exception. And then we say, sorry, try again. And so this is actually recursion, meaning that it'll go back up to here, and then it'll try again. And if it gets the wrong answer, it's going to go back up to here, try again. And if it gets an exception, it goes back up to here, tries again. All right, so let's try that guy. Input, in, there we go. So if I type in Fred, well, that can't be converted into a double. And it says, enter a number, dude. Well, if I type in an F, enter a number. So I type in 124, there we go. The number's 124. So it keeps prompting us and recursing back and up and up and up until you put in the right answer. So recursion means using a function to call itself. So we're not exactly using a function to call itself, but we are going back until we get the right answer. Now, real recursion is when we call the function from within the function. Okay, so yes, there's a good one. So we're going to do a countdown with recursion function. We did a little recursion with Python. I don't think we did any with Java. So we have a couple functions, right? We have our function prototypes. Count down from, we put in the number that we want to count down from. We can count up to something with from and to. Okay, so we count down 10. We count up to. All right, so let's look at how the recursion works. Well, we start out calling the function the first time. Say we pass in a 10. Is 10 greater than or equal to 0? Yes, it is. So we print out a 10. We then subtract 1 from that number, which makes it 9. We call the function again, does the same thing, prints out the 9, and then next time it's 8, and the next time it's 7, 6, 5, 4, 3, 2, 1, 0. And after that, we're done. Because it no longer passes the test, we go out of the function, we come back to here, and we move on. Same thing with this guy. So we're going to count up to, and we have our from and our to. So as long as the from, which is the starting parameter, is less than or equal to the to, we keep going. We keep calling the same function again and again. Now, can you do this with a loop? Absolutely. You will run into problems like this. You'll run into situations where maybe recursion is a quick way to solve the problem. Is recursion very common? Not so much. So we print out a space, and we print out the first time, we print out the from number plus 1, and then the 2. And let's just see how this thing works. This is called countdown. Oh, I opened up the file. That's not what I wanted to do, because I already had the file open. Let's try that again. There, now I'm in my console. Let's get the executable. There. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10, 0. There we go. Using recursion to go 2 different ways and a couple different methods of recursion. Now, we're going to get very interesting. We're going to look at a concept called pass-by reference. Most of the time, we have been, when we call a function, we pass a copy of that information, and this is a brand new function, normally. Okay? In this case, we're going to create a reference variable, right? So these are going to be a reference to these two guys, which means when we pass them in, this is going to be the same variables. A reference means that we have an address that's referencing the contents of these two variables. If we change these two variables, they change back here also. Here we're working with the reference to the variables, and here we're working directly with the variables. So a reference means that this one is not a copy. These are both referring to the same variable address space. Do we have to have the name num1 and num2? No. We could call this number1 and number2. These are, in fact, that might be a better illustration. These are number1 and number2, but they refer to the same variable. So a reference means that we're saying, oh, well, this isn't really a variable. It is a pointer, which it really isn't a pointer, but it is a reference to this variable. So we can either change this, or we can change this, and we're changing the same variable address. All right, let's run that. I know that's kind of an interesting concept, and I don't know that running is going to prove it. Well, I guess it will. Let's try that. Let's see if we can get it to work. So far, everything has worked. There. So here we printed out 2, 2, right? And we printed it out right here. We changed them both to 2. We changed the reference. Well, the reference is pointing to this. This is where the values are stored. The reference is a memory address that points over here. It's not pointers. We'll get to pointers later on. But it's referring to this variable. It's very similar to pointers. So with C++, we have a lot more control over how we put things in memory and how we address things and how we work with things. On the flip side of that, it's also much more dangerous. You can end up crashing programs, and in fact, the White House says you have to use data safe programming, memory safe programming languages, which C++ is not memory safe. Java manages memory for you. Python manages memory for you. C++, you have to manage the memory, so you can make a problem. So now our last one is to do I have to be in a different folder. Just a second. It's easy peasy to have multiple files together in Python. You just have to include it. With Java, they just have to be in the same folder. Well, with C++, it's a little different story. You have a little more wiggly stuff going around. So let's take a look at how that works. So here is my main, right? I'm calling the function. Now I do have to include the header file. Well, what's a header file? Let's take a look at what a header file is. Notice there's 3 files. So if I'm going to include a function in a separate file, which would be a module in Python, I actually have to have 2 files. So what's the header file doing? Well, the header file is basically defining the function. It's a function prototype. These are guardrails. This guy and this guy are guardrails, the end if, to make sure that we can't import it more than once. It's a very common way to write a function header. Well, so far we haven't seen the function yet. Oh, there it is. So we define the function in a separate file, and we have to also include the header so that when the C++ compiler goes down the road, it compiles things and says, oh, I know where everything is. So is this a little more complicated? Yes, it is. So our main has to include the header file. Our function function prototype, this is the function definition, it has to include the prototype. So the prototype is a separate file. This is a separate file. This is a separate file. So how do we compile it? Well, if you just compile main, it's not going to work. So that's why I've discovered for me it's easier just to create a little batch file. So G++ is our compiler. -O says this is going to be the output. And then, of course, we need main. And we include the other function file. That automatically includes function.h because, oh, here it is. Because this includes that file, so the header file is automatically included. So if you double click that, it will compile these guys together and we'll end up with myprogram.exe. And it does work. And as we do other multiple file programs, you can reuse this again and again. So if I double click on it, all things being equal, yeah, see it does a little buzzing and whirring. There's no errors. And I have my program. If I double click on it, it's just going to disappear because I have nothing that stops it from running. Stops it from exiting. So I have to go here and do the, what did I call it? My program. .exe, there it is. So that puts these 3 files into a single executable. Yes, that's a little different. When we start doing object-oriented programming, it will use the same paradigm of headers, separate file, and then the application file. With C++, you always have this extra little prototype file. So it's not so bad once you understand it. It's fun. Lots of students really like C++. I've always enjoyed working with C++.